Yeah, today we are going to start with the new topic, that is the chemical equilibrium, right? But before we do that, you should be familiar where this chemical equilibrium is going to apply, or to which kind of changes or the processes we come across it applies, right? So before we start with it, you should know that this chemical equilibrium applies to a mostly, you can say it applies to a physical as well as chemical process, but there has to be a chemical reaction to occur in which the chemical equilibrium will apply, right? So before we start with it, I am telling you about the chemical reaction, what exactly it is. So the chemical reaction is that, like for example, I am saying that I am mixing two substances, two or more. You can take two, I am taking two substances, you can take more than two substances as well, or you can start with the one substance as well, right? So the chemical reaction is actually a process in which the few substances I am mixing and they just form a new substance. So this kind of this process is called a chemical reaction. So what is it? In this reaction, I just say that I have just mixed this A and B and they just unite to give me a new substance. So that means it is a chemical reaction, right? For example, I'm taking an example of a daily life. Suppose we are making tea. So what we do when we make tea? We add water, right? We add milk to it. We add a spoon of sugar to it. We add tea to it. Then we heat it, right? And after some time, they just all unite to form a common substance, that is the tea. So that means the substances that reacted are water, milk, sugar and tea leaves, right? And when they form a new substance, the new substance that we get is obviously a tea. So that is also a chemical reaction, right? So chemical reaction is actually a process in which we just mix few substances and they just unite to form a new substance, right? And this arrow is just indicating that these substances are now transformed into these kind of substances. These were the original substances which we took, and these are the new substances that are formed due to the transformation in the reactants, right? Now the question must be arising in your mind that how the reactants just transform into the products, right? So what is the reason behind? What happens when these reactants are taken, they just collide among themselves, right? And when they collide, they get a, you can say, a kind of mysterious force which appear as an activation energy, which break their initial bonds and leads to the formation of new bond. That is why they get transformed into a new substance. I think you are familiar with the chemical reaction now. Again, I am repeating the reaction for you. It is actually a process in which the substances just react to form some new substance, right? And the substances which we take are called as the reactants, and the new one which are formed are called as the products. For example, like earlier I took an example, a general equation example with A and B. Now I am taking an example. Suppose carbon mixed with oxygen gas give rise to carbon dioxide, right? So in this case, what are reactants? Obviously these are initially mixed, so they are regarded as reactants. And the new one that is formed is carbon dioxide, so it is product. Right. So this is a chemical reaction, and the method by which I have just expressed this chemical reaction is a chemical equation in which we just use the formulas, moles, and we specify the states as well, or any kind of changes that is occurring in a chemical reaction, like the energy is released or heat energy is absorbed. What are the changes which we are observing? We are just indicating in the chemical equation, right? So this is the chemical reaction. Now, the chemical reaction is not limited to only one kind of reaction. There are many types of chemical reactions which we come across. Like you must have studied in your previous classes as well, there is a combination reaction in which we mix many reactants but they give rise to only one product, right? There can be a decomposition reaction in which there is one reactant, it splits into many products, right? It can be a displacement reaction in which the more reactive element displaces the less reactive element, right? It can be double displacement in which the mutual exchange of ions take place. So that means, like as I've told you many examples, so there are many types of reactions which are taking place, and there are different types of that. Like, but in the chemical equilibrium we need a reaction of like we are considering one kind of reaction which has to be taken into the consideration where this equilibrium is being applied, right? So that kind of reaction I am stating you with an example. Suppose I am adding silver nitrate solution to sodium chloride, right? I have taken silver nitrate solution and a sodium chloride. I am just mixing them. Then what is going to happen? You can see that it is a kind of two compounds are there, so that means it is a double decomposition reaction, right? So I am just writing the valencies, because whenever you want to complete the reaction, just write the valencies on the top. It will be you can say it will be more clear for you to just complete the reaction, right? So I am just writing the valencies as a superscript, right? So you can see that Ag is going to combine with Cl, so we are going to have AgCl, and along with it Na is going to combine with nitrate, and we are going to have NaNO3, right? AgCl just form the precipitate. That is why I am putting the arrow down, that it indicates that AgCl is left behind as a precipitate, right? So but our point of discussion is that yes, though it is a double decomposition reaction, but still the type of reaction which I am going to make you understand, just look at the board carefully. What is going to happen in this reaction? When silver nitrate is mixed with sodium chloride, we get silver chloride and NaNO3, right? So can I have AgNO3 and NaCl back from AgCl and NaNO3 in a given set of condition? No, we can't, right? Because once the AgNO3 and NaCl gets converted into the AgCl and NaNO3 at given condition of temperature and pressure, we cannot have the reactants back. That means we cannot have the AgNO3 and NaCl back from the AgCl and NaNO3 at a given set of conditions, the same similar conditions at which these reactants combine to form product. We cannot have, right? So that means this reaction is going to occur in only one direction, that is, it is occurring in a forward direction, right? So one more example I am considering for you. For example, I have this nitrogen, I am mixing with hydrogen, and what happens? There is a temperature, high temperature, there is a catalyst 2, iron, and the catalytic promoter also we have molybdenum oxide. Then what is happening? This N2 is combining with H2 to give rise to ammonia. This is occurring at particular temperature and particular pressure. That means temperature and pressure conditions are fixed. Now, what do we observe in this kind of reaction? We observe that when N2 combine with H2, they obviously give rise to NH3. But what happens? As the amount of NH3 increases, so at the same condition of temperature and pressure, it is getting converting back into the reactants, that is N2 and H2. So that means under the given set of conditions of temperature and pressure, we can have the N2H2 back from the NH3. That means the reaction is occurring in a forward direction also, and the reaction can occur in a backward direction also. The pressure and temperature conditions remaining the same. So that means for any reaction to occur when it is occurring in a forward as well as backward reaction at the given set of condition of temperature and pressure, that reaction is said to be reversible reaction. So that means it is a reversible reaction in which the reactants can give rise to products, and at the same time the products can give rise to the reactant back. But if we compare this kind of reaction with this above example, I told you that under the given set of condition of temperature and pressure, we cannot get AgNO3 and NaCl back from AgCl and NaNO3. We cannot get. So that means once they will form the product cannot form the reactant back, right? So that this kind of reaction is considered to be irreversible reaction, right? So why like I am just making you studying like as I told you that there are so many types of chemical reaction, but for chemical equilibrium we need the reversible and irreversible reactions to be considered, right? Now what is the logic behind that I am telling you to just you can say that just concentrate on these kind of reactions, or why we get to see the chemical equilibrium in only these kind of reactions. So just keep in mind, whenever we are going to study the chemical equilibrium or the equilibrium, it happens only in case of the reversible reaction. It is, you can say, an application of the the reversible reaction. It doesn't happen in the irreversible kind of reaction, right? So I think you are clear with it. I'm just repeating again for you. So chemical reaction is a process in which we just mix few reactants and they just unite to give products, right? The reaction can be of many type, like if there are many reactants but one product, it is combination reaction. When it is one reactant and many products, it is decomposition reaction. And when some metal is just exchanging the place, so then it is displacement. If two ions are changing their place simultaneously, then it is double displacement reaction, right? But we are considering here is an irreversible and reversible reaction. Irreversible is that in which products cannot unite to give at the given condition of temperature and pressure, they cannot give the reactant back. And the reversible is that kind in which we can, at the given set of condition, we can get the reactant back from the product. That means the reaction is occurring in the either way. It is occurring, this N2 and H2 is just combining to give NH3, and at the same time the NH3 is also getting dissociated into the reactants back, that is the N2 and H2 we are getting back. That means the reaction is occurring in a forward direction also, and it is also occurring in a backward direction, right? I think it's clear now. Now, where this equilibrium is used, or what do we mean by the equilibrium in the case of the reversible reaction? Now, I am going to explain you that what do we mean by the term equilibrium. Now, I am taking a general example. Suppose we consider a reversible reaction. Suppose A plus B unite to give AB, right? And as I told you in a reversible reaction, under the given set of condition of temperature and pressure, AB is just dissociating back to give A and B, right? So this is a reversible reaction. That means they are just combining. That means the forward reaction is also occurring as well as the backward reaction is also occurring. Now what happens, as the AB is combining to give AB, and at the same time AB is just combining to give the A and B back, we'll reach a stage, a certain stage, when the rate of the forward reaction will become equal to the rate of the backward reaction. That means, again I'm repeating, what does it mean actually? It means that you can say this is the speed at which A and B are combining to give the AB is just similar to the speed at which the AB is getting dissociated into A and B. Or you can say the equilibrium is a state at which the concentration of the AB present is equal to the concentration of the A and B present. So that is called as an stage of equilibrium, right? So equilibrium is not achieved as we start a reaction. Equilibrium is never achieved as soon, right? It occurs with the passage of time. For example, I just mix A and B. So what is happening? The concentration of A decreasing with time, the concentration of B decreasing with time, right? And simultaneously the concentration of AB increasing with time. When the sufficient amount of AB is formed, then what happens? With the passage of time, these concentrations remain unchanged. So that indicates a stage of equilibrium. So what happens at equilibrium? At equilibrium, rate of forward reaction becomes equal to rate of reversible reaction, or we can say the concentration of reactants become equal to the concentration of products. So it is not like that the reaction is not taking place. Reaction is taking place, but the rate at which the reactant is forming the product and the rate at which the product is forming the reactant just become unequal. Reaction is still taking place. So equilibrium is not static in this case. Static means the reaction has not stopped, right? The reaction is still taking place. So we say that equilibrium is dynamic in nature. Equilibrium is dynamic in nature. That means the reactions are still going on. It is not, the reaction hasn't stopped, it is still going on. And as we'll proceed further, I'll tell you an example as well. We'll conduct an experiment as well, so as to know that what proves that the equilibrium is equilibrium state is a dynamic state, or the reactions are still going on when the equilibrium is achieved, right? So how you're going to define the equilibrium? Equilibrium is a stage when the rate of forward reaction just becomes equal to the rate of the backward reaction, or we just get to see the constancy in the properties of the concentration, pressure, temperature, or whatever the property we are going to study. All the properties just remain the constant. So just keep in mind the reaction hasn't stopped, it is still going on, only the rate of the forward and the backward reaction becomes equal. So that is why I told you about the reversible reaction, because this equilibrium applies only in case of the reversible reaction. The only criteria to have an equilibrium is that there should be a reaction which is reversible. That means the product has the tendency to convert back into the reactants. This equilibrium is never achieved in case of the irreversible reaction, because it is achieved only when there is a tendency of reactant to get converted into the product, and the product gets converted into the reactant. And the condition which is necessary is that we do not have to change the condition of temperature and pressure. It should remain the same, right?